This is quite unusual for a manufacturer of humidifier, what I will tell you, but mainly if you think twice before to calculate the load, and if you take into account other factors that usually are used by engineers, you will be able to save a lot of energy on the steam ramp, okay, on the construction of the steam distribution ramps. And then you can save not only money on the initial investment, but over the years of operation of the humidifiers. So first, we will look at the parameters of the relative humidity load calculation. How do we calculate this? Some of you guys have heard this many times, but it will be one more time, and for the others, but it will be interesting to know what are the different parameters. Comparing heating mode and the economizer mode. Some question about the most common parameters, and then we will have two case studies. One which is a school in Montreal, and the other is a laboratory in Milwaukee. This is two jobs or projects that we have quoted on, okay? And then we finish with some tips how to save energy. All right. So the parameters are, of course, the outside condition. The OA means outside condition, of course. So as cold and dry that you will be, as more humidity you will need. Then the load will depend on the application. So then you have the ASHRAE guide telling you for an office building, it should be between 30 to 50%. That's what some people now are, and the research are telling that the 40% should be the new minimum. If you have a laboratory, you should have 100% fresh air. If you have, depending on the laboratory, if you have office building, again, the quantity of fresh air will be, or outside air will be depending on the system you are using. The supply air condition will be important too. And then the room condition, or in other words, the set point, okay, which temperature you want in the room or in the space, and which relative humidity. Marijuana growing facility, for example, they need the early stage of the growing. They need a lot of humidity, and it's quite hot. So they will need 80 to 85 or 90% relative humidity in the room. And then they have too much humidity when during the flowering stage and when the plant is more mature. So then they will have to remove humidity from the grow room. So the first information is or the first step would be to define what are the worst possible condition for humidity. Is it the heating mode? Is it the economizer mode? Or is it another mode? Okay. In Montreal or in the north part of the US and Canada, most of the time it's a heating mode. But let's talk about Arizona, when it's can be very dry and hot during spring or during fall. Then maybe the worst condition would be economizer mode, okay? Or when the economizer means that you are using the outside air to cool, and you are bringing more fresh air than you are bringing during the heating mode. Where can we place the humidifier? That's another important parameter that sometimes it's not well thought in depth by the engineer, because they have sometimes just copy and paste what they have done in the past, and they have an air including, so let's put it here. They used to put it into the duct, or where is the best place? For example, marijuana growing facility, you are cooling. You are bringing a lot of cooling in from the supply air into the room, and you want a lot of humidity. So what will this means? It's inside the duct. You don't have the perfect condition for humidification, because you will condense all the steam or whatever water that you will bring into the duct. So the best position for the humidifier in marijuana growing facility here it is inside the grow room, not inside the duct. Or you will have to plan very carefully where in the duct you will place the humidifier, and you will have You will hit the saturation very quickly. And then do you have a VAV box? Do you put the humidifier just before a VAV box? VAV means variable air volume. So if you select this, you will bring a lot of possible trouble because you will have less air, possible less air in different conditions. So if you have less air and the same quantity of humidity, you might bring some trouble. So you have to think about it. Let's compare the heating and heating mode and economizer mode. Heating, so the different parameters are, dry bulb and wet bulb outside temperature, or temperature and relative humidity from the outside, and the air volumes. Of course, if you have more air volume, you will need more load. If you have less load of humidity, and then the set point temperature and humidity into the room you want to humidify it. And as I said, what is the application? This is a typical air handling unit. You have the fresh air, outside air, mixed air, the return, and then you can play with this one, and you can then bring some more fresh air or more return air, and then you have reheat, cooling, the fan, filters. You can have more filters, you can have the cooling and heating placed differently, but basically it's the different element that you have. So for heating, the percentage or the quantity or outside air you will bring should be the minimum. This is obvious. You want to heat up as little little air as possible, because that's very expensive. You will spend a lot of energy for this. So you want minimal outside air, and if you are in economizer mode, that's a reverse. You want the maximum fresh air, because you want to use the air that is typically in Montreal, like it is today. It's 9 Celsius, or about 50, 47, 48 Fahrenheit today. It's a beautiful day, sunny. You want to use this. You want to use it to cool down, or to bring more fresh air, and you will have all the occupant more more comfortable by doing so. Then bringing a little bit of fresh air, because then you have more CO2 here. So I would say it would feel more or less comfortable, and you don't have to use the cooling if you bring some more cool outside air. So the different question parameters that you should ask, you can ask the engineer when you are involved in the design. The airflow, is it variable? If so, you should consider the minimum airflow during the worst condition. Outside air, CFM. When I'm talking here about airflow, it's about the total airflow. Here I'm talking about the outside air bringing it. Is it variable? Can you play with it? If so, can you consider to lower the outside air if the application allows you to do it? What about the room RH humidity? If the application is allowing you to have like a window, minimum and maximum allowed during the worst scenario, which is the heating mode, so the coldest day of the year, you should have the minimal relative humidity, and then you will know that you will be able to fulfill any other relative humidity inside the room or inside the space for all the other days of the year, because you are taking the other air parameters will help you help you to meet the demand. The outside air temperature, how many days a year you will have this worst condition? Is it one day? Have you where did you take this worst condition? Is it from a table of average condition over the 10 years or over the past 3 years? You've probably heard about the global warming of our planet. So the worst condition 50 years ago might not be the same as today. So if it's one day a year that you will have this worst condition, maybe you can say, oh, for one day I will not beat the demand. Is the application allows me to do it? If so, why not? What is the type of building? Do you have human being in the building? Is it a data center, or is it with 3 technicians running around the computers every day? Or is it an office building with, 1,000 person, or a school with 2,000 students, or university? You know that everybody, every human being, when seated, will evaporate about 0.2 pound an hour. And if he's active, let's say going to a gym or doing some, just moving like in a factory or so, it will be about 0.5 pound an hour. If you don't take this into an account, then you will have probably excess capacity for the building that will be occupied. And the supply air temperature, which temperature you will humidify. Everybody is, in North America is taking 55 Fahrenheit. 55 Fahrenheit. Why? Because that's a laboratory condition. So everybody has been tested for many years at 55 Fahrenheit. So they put this into their spec, and the engineers are copying them and so on. But is it really 55 Fahrenheit that you have in the duct? If not, you should put this temperature when you calculate the load. So let's look at the first case study. It is a project that we got about 2-3 years ago. Some of you have already probably have this example. So it's the load indicated on the drawing is 213 pound an hour with a 14,000 CFM and the duct 48 by 48. And they want absorption distance or non-wetting distance, and WD means at steam overlap non-wetting distance at 10 inch, which is very, very demanding. I did it already. I have a little link to the SteamoCalc, but everybody knows SteamoCalc. I already entered this information into SteamoCalc and got the information. I will go there and look at this with you. We entered the value into SteamoCalc, and we got this. So we have 14,000 CFM here. We have 35% relative humidity in the room. The duct is 48 by 48, and we enter what should be the minimal condition, -5 Fahrenheit, 50% relative humidity outside there. And then to get to the magic number 2, 10 to 13, we have to bring in 62% of outside air, which is a lot at -5 Fahrenheit. A lot of heating load. And then we have here on the second page what steam dispersion ramp we should use. So to be able to meet with here non-wetting distance, okay, this column. So to be able to go to the 10 inch, you see how many ramps we need. We need 10, 11 ramps. And you will have 4 inch between each ramp. Okay, what you see here, it's a new version of the SteamoCalc that will be released pretty soon. And you see here, it's not yet translated, but it's a pressure drop here. So you have the different pressure drop. This is in Pascal. We will display it, of course, depending on the unit that you will select here, imperial or metric. That's what it is for what the engineer were asking for the school. Let's go and look at what we were thinking should be good for this application, should be appropriate for this application. So we reduce the amount of fresh air during the worst case scenario or the outside air in winter to 30%, because who wants to eat up so much fresh air? Okay, so then you divided the load by 2. This is an extreme example, I would say. And here you have the economizer mode. That's the same for the both calculation. So then you got 83.5 pound an hour. So even during when you bring a lot of fresh air during the shoulder season, you will have enough of humidity to satisfy the load. If this is becoming bigger, the economizer becoming bigger than the heating mode in Montreal, you should ask yourself, maybe I am a little bit too much optimistic for the heating mode. So let's go back to table. So this is what you see here. So the 62% outside air, and here 30% amount of outside air coming in. So here we have 11 tube, here we have 6 tube, and economizer we will have 5 tubes or 5 vertical ramps if you prefer. The entering air condition and the leaving air condition, and here you have the pressure drop in inch of water column. So 0.08 or 0.03. So we divide it by half. I am a more visual person. So you see, this is up to scale what would be the steam distribution ramp for the 210 pound and for the 100 pound. So you see that we are practically blocking the air with this solution here. That's what the engineer asked for. Other factor to consider that we should maybe open or talked about the engineer when he's doing this calculation. When you have -5 Fahrenheit outside air, if you keep 35% relative humidity into a school with a lot of windows around, you will probably condense on the windows. So maybe you should consider lowering to the minimal that ASHRAE or that the experience is telling you. So maybe you should. And what do you know about the building? Is it a brand new building? Is it a replacement renovation? What are the specifications of the window? The latest design? You don't have any insulation or double or any specific, I would say, any specific way to insulate the window. So if you have this, and the engineer will have this information, if it's, let's say, a typical windows that we found in the old school, you should lower the set point into the room when you are doing the worst case scenario. So then you will lower again this. And how many occupants in the school? This has been taken in account. In SimoCalc, you don't have this ability, but you can simply with your calculator enter this factor easily or this information at the end, okay? And then you will be able to lower a little bit the load. I have some question on the chat, so continue with the question. I will look at them and answer the best I can at the end. If not, I will take the question and answer to you later in the day, okay? The second case study is a laboratory. So it's quite different as a school, okay? Laboratory, sometimes they are very specific conditions. So this one came in 2 weeks ago, 100 pounds an hour, 8,260 CFM, 30 by 30 inch duct, and then 24-inch non-wetting distance. So we have more non-wetting distance, but we have a very small duct, very, very small duct for this load, okay? And when we see this, we always think, oh, it will be a possible problematic job, okay? Because you know, when you put a lot of steam into a very small duct, you are adding more risk to condense into the side wall and so on, and to block the air with the steam distribution ramp. So for this one, again, I will go and look at the SteamoCalc here case study. So the first one is this one, 500 feet above the sea level. In the table, there was information about the calculation has been done at 11,000 CFM, but the duct CFM inside the duct where the steam distribution ramp is, it's 8,000. So, and they specify 670 Fahrenheit and only 15% relative humidity into the room, which I found it very low, but this is what they asked for. So in the table, there was this information: 10 Fahrenheit, minus 10 Fahrenheit outside air, and 2% relative humidity for the outside air. So same information here. And here you see this. And then we finish up with 120 pounds an hour. And the economizer mode, which I entered even if what it was not indicated, it's only 26 pounds an hour. So this can tell you that a big difference. Let's look at the steam distribution ramp. So to meet the 24, you cannot go with a single ramp, because then you will have 18 and you need 3 ramps, and you have a lot of steam to put. So because of this, you have no choice but to use a vertical ramp, the SOS model. So then you can use any of them that are 4 or 5 ramp. Okay. And then if you go back to the question I was asking myself, why he consider so little humidity in Milwaukee for the outside air? I know that most of you will think, oh, Bernard, at this temperature, it doesn't make any difference. Yes, but you see, minus 10 Fahrenheit, even in Montreal, we don't take this low temperature. So I considered as an outside, based on the information I found on the web, 0 Fahrenheit for Milwaukee, and around 50 to 60 or 70% relative humidity for the outside air. And then here I'm 91 pound an hour. So now the humidifier is not a 2 module anymore, it's a 1 module. And then you can have only 3 ramps instead of 4, and less pressure drop. So that's a 2 scenario I was looking at. The difference here, it's not as much. So here it's 3 tubes, sorry. I mentioned 5 and 4, so it's exactly 4 and 3, 55, 0, 55, 5%, 25. And here you see again what you are gaining on the pressure drop. So again, I don't have the graphic showing you the ramp, but again, we'll have more space to have this, put the 91 pound. Although I would question this also to the engineer, 15% or more. So then you will tell me, or the most common or the most common reaction to how to save energy would be to put insulation, right? But before to put insulation, let's consider reducing the load. So here I presented here and that's another information that we will try to put available on the SteamoCalc. So then it will help you maybe to indicate to the engineer how much it will save. Okay, so the first, this is the school and this is the lab. Yeah, so the school here and the lab. Okay, and here I will put S. So 11 tube, 0.08 inch of water column. Without insulation, you will lose this amount. With insulation, you will still lose 9 pounds. And if you take 30% outside air instead of the 62, so then you reduce the load, then you have practically the same as if you put insulation. And then if you put insulation, maybe you will tell me it's not anymore relevant, but it's still it's still a difference of about 8 pounds that you will save by putting insulation. And here I did the calculation here between the 2 scenarios. Okay, and the same here for the lab. So here you have 10 pounds or 4 pounds of condensate that you will have at the end of the ramp, and here you will have about 9, 8.8 or 3. So it can be also an avenue, I would say, but first you should question always the parameter that you are using to calculate the humidification load. Why? Because in humidification, it's not like in heating. It's not, yes, the customer will pay more, but a bigger is not better. And the good design is, it should be enough, of course, That should be the first one, okay? Enough, but not more than enough. Because then as soon as you put more than enough, you are losing efficiency. And then how you will distribute this steam in the duct, that's another question that you should always ask. How I will put this steam into the duct. And maybe for the lab would be to make a little bit bigger a duct for this amount of air volume going in. Okay, when you are above 1,000 feet per minute into the duct, it's not the best condition to put the steam. So this is the parameter to that will play and that will give you the non-wetting distance. So that's a difference between what's the entering and the leaving condition of relative humidity before and after the ramp. Of course, the quantity of nozzles and the spacing in between the tube. And the smaller the steam distribution will be, of course, you will have less losses and it will be better. And then I'm finishing with the tips that we always give to every engineer we are meeting. Avoid large difference of entering and leaving condition of the what they call sometimes humidifier or the steam ramp. What's in and out. If you have a large difference, you will have possible trouble because the air will not be able to absorb this. Avoid very short distance if you can. Very short non-wetting distance. Avoid transition or filter because then you will put all the humidity into, or the filter will act as the catcher, and it will all the humidity will condense onto the filter. And avoid distance between tube, so this here and here or here, of less than 3 inches. On the Stimocalc, you will see the information and we can go down. We are displaying everything. But if we receive an order for less than 3 inch, we will call you and ask you why, because you are going into troubles and into a lot of losses. So in fact, you think you are doing good because you will put more steam into a duct, but in fact, you are not putting more steam, you are putting more condensate. So the 5 questions that, again, we are pushing a lot to the engineer community. Do I really need this capacity? And this is not typical from a manufacturer of humidifier to tell an engineer this, because we like to sell bigger the humidifier, happier we should be. Not necessarily. We want the best solution for the application, not the biggest, where we will make more profit. Because at the end of the road, if the customer see that he has spent so much money and that the installation is not performing well because we pushed on the big humidifier, we will be the one to blame. And then, so do I need this recapacity? Then the question is, how many days a year will I need this capacity? Is it 1 day? If it's 1 day, maybe I don't need it. Do I have alternatives, such as lowering the room relative humidity during the coldest day or reducing the amount of outside air? And what is the percentage of relative humidity at the outlet of the steam pipe? If it's above 70% relative humidity, then you might have a lot of losses and you might have trouble of condensing downstream, okay, or very long non-wetting distance. And what is the difference between entering and leaving condition? If it's above 50% relative humidity, the difference, then maybe you should reconsider. Again, this is question. If your applications tell you, yes, I need this, yes, in this application, and you answer yes everywhere, then okay, we will try to make it work and to do it the best way for you. But you have to know that you will have losses, and then maybe it will be a good idea to put insulation on the steam ramp.